the things that from today's lecture will be covered for your case study. And this is the final lecture where the case study assignment will be covering, meaning in SDLC, we have our system planning, system analysis, and then PAD. So the next D is system design. Okay, PAD. So your case study only covers the first three phases. Okay, PADDIO. So we're not going to cover system development. We're not going to cover system implementation, and also system O is operation. Okay, operation means the system support and security, also known as maintenance. Our case study covers your speed bus covers up until design, meaning you need to design the structure chart for your modules, and these modules is based on your DFD, right? And then I think you also need to design the user interface screen based on the attributes that you have designed in your database design. Okay, and then what else? Database design. Oh, now I remember. We will cover. Let me see. Today is not the last one. We will include a database design in week 6, because some database design is also required in your case study. Okay, so user interface design, input validation design, report design. All these are covered in your case study. Okay, let me ready my slide first. One moment. Okay, so I'll start with the course plan first. This is what I mentioned just now. We will finish off system and interface design, right? And then this Thursday, you will present your feasibility study, and your in-class work would be on the fact gathering, interview, and questionnaire. Next week, we will cover database design. All right, so that's our course plan. Okay, so let's continue with what we have here. Okay. Before that, I believe I need to show you the case study. So up to last week, we have covered until week 8, right? And then this is what I mentioned, functional design. I'm not sure whether for your programming, problem solving and programming course, right? You have learned how to draw a structure chart. Okay, a structure chart where you have the system name at the top, and then Below would be several modules or rectangles to represent the sub-modules. Okay, but then for the diploma student, they learn how to draw this. So I hope this is also covered in your programming course during the first sem. Did you cover this?
Yeah.
The structure part? Okay, good. At least you have some kind of idea. And then here I notice even though for your DFD, okay, let me see, for DFD, you only need to draw up to diagram 0. Diagram 0 would be your processes. So you have process 1, 2, 3, 4, 5, 6, which include file maintenance and reporting. 6 processes, and then there's no need for you to draw diagram 1. Diagram 1 would be like, for example, if you choose process 2 to be exploded, then you will get 2.1, 2.2, 2.3, something like that. So diagram 1 is not required. However, when I look at the week 9, it says that for any 2 of the second level modules, means if in your diagram 0 you have 6 processes, means in your structure chart you should have 6 modules. That's how you convert or translate a DFD into your structure chart. The processes will become modules. All right, so 6 modules in your what is this, the structure chart, and then out of the 6 modules, 2 of the modules you are required to provide brief but relevant description of the functions, and then must have a minimum 4 major functions. So out of the 6 modules, you need to provide 4 major functions for the 2 modules that you have selected. So meaning, say you explode process 2, so 2.1, 2.2, 2.3, 2.4. By right, if you already have diagram 1 here, you can easily translate it to your structure chart, because you already know 2.1, 2.2, 2.3, 2.4. You already know what are the sub processes, sub modules. But since here it is not required for you to draw that, so I just want you all to bear in mind that let's say in week 9 you need to like somehow understand for each of the process that you select here, only 2 lah, or module, 2 modules, you must know what are the major functions for each of them. Okay. Besides the structure chart, you also need to design the user interface for the data entry. And then here it says to match with the source document. I believe this part is not yet updated because for the diploma student, they need to design a source document before they design data input screen. So since for yours, the source document has been removed, so there's no need for you to design the source document anymore lah. So let me strike to this one, okay, because it's already been removed. So you just need to design your data entry screen, okay. And then your assumption would be yours would not be an online input, right? Okay. Validation check, we will look at examples of validation check, but then I believe for your programming course, you have learned something about how to do input validation. We will cover this as well. This one I will explain after we have covered next week's lecture, which is the database design. This one is also database design. Week 11, 12, database design. And finally, this is the final presentation, okay, case study for week 13. This is where you need to come up with reports, okay, reports. One thing that I find that it's much more easier for you guys compared for the diploma, because I need to mention this because I might show you their work, okay, as an example. They need to come up with a report, and then for you guys, I can see that there's no need for you to do that, okay. No actual reports are required. You just need to list inside this table what is the name of the report, the content, who use it, and the purpose. Okay, so we'll cover up to the report design for today's lecture, right? So I hope you will pay attention. Okay, let me start the recording. All right, so for chapter 5, system and interface design. Okay, let's, you can see the slide, right?
Yeah.
We always see this. Okay, this time we are in the system design. Now, based on the list of requirements that we get, all right, we will try to now design the proposed new system. Okay, so we have the user interface design, procedural design, functional design, report design, user interface, and everything, even database design. So all this will be compiled in one output or deliverable. We call it as SDS, System Design Specification. This is what will be used by the programmers when we enter into the system development phase. So during system development, this is where system analyst will provide the system design specification to his programmers, so the programmers can start doing the coding, okay, the system development. So the system design is very important in order for the programmer to do their development, software development. And remember, the system design depends on the SRD, the system requirements document. So if the system analysis is not done appropriately, or there's a mistake, or there's a missing information, then it will affect the rest of the phases. Now let's start with what is a system design. Okay, the keyword here is how. Okay, from the system design, the design itself will show to us how the system will fulfill the functionality of the proposed new system. So it can be something like a blueprint, okay, a blueprint or overall plan that consists of all the specifications here, design specification that I mentioned just now, the functional design, procedural design, user interface design, report design, and so on. So who will be doing all this, the system design? Here it is stated the designer details the system specification. In this case, it would be our SA, system analyst, right? Next, in this slide, it shows us the importance of design. It means, why can't we, okay, let me go back to the previous slide. Why can't we, or we already have the system requirements. Just like when you do your programming assignment. You have the assignment specification. You have been instructed that the system that you need to program must be able to do this. The output will look like this. But then do you notice that the sample output and everything, that one is supposed to be in the system design, means the question already more or less give you ideas what you need to do. All right, so it is somehow your assignment question already combine these two, the requirements and also how it should look like. And then that's why as a programmer, you can start doing your assignment, right? But then in real life, okay, in real life, you need to come up with your own design based on the system analysis. So we need to really understand the importance of this part. Okay, what will happen without this system design phase in SDLC? So let's take a look at the importance. First of all, we can always go back to our system design when we conduct any maintenance. Okay, maintenance means any modification or upgrades. Because in the system design, it shows the database design. In the database design, for example, it lists out how many tables, what are the attributes, primary key, foreign keys, if in case the maintenance requires adding one additional table. So need to refer to the database design during the maintenance. This is one example. If say, for example, you need to change something else, perhaps the reports, then you need to look at the available report design, and then you have the overall idea to start with the report modification. Then next is equality. Here with the system design, because we have already come up with the design, when we want to somehow like do a postmortem whether the completed new information system is of high quality, means it fulfills the requirements, then we can always go back to the design and then use it when we want to assess it for quality. Okay, next, testing. All right, from the user interface design, perhaps there will be, you need to also come up with the input validation. Here it will help in the testing of the software. Okay, and then another thing would be that remember, SA will provide the system design specification to its programmers, right? So this SDS will serve as a communication, okay, when they communicate during the system development phase. And then one more would be the implementation, whereby we will use the system design, okay, to translate the customer's requirement into a finished product. Remember, from where do we get the customer's requirements? From the previous phase, which is the SRD, the system requirement document. So I really hope that by now you have already memorized this part. Okay, the important deliverables by from each of these phases. Okay. As an overview, all right, these are the areas of design. Remember, we have the system analysis phase and also the system design phase. In system analysis phase, last week we have learned how to draw DFT, ERG, but then not UML diagram. UML diagram, I believe you learn it in your object-oriented programming. You all have learned object-oriented programming, right? Or are you all learning it now through visual programming?
Oh, yeah.
Okay. UML diagram is meant for object-oriented programming language, right? So notice that these are the models being prepared in the system analysis phase. And then during the system design, phase, these are what we need to do. Next week, we will cover database design. Today, we will cover the interface design, procedural design, I believe, after database design, if I'm not mistaken, and architectural design, we will cover first. Okay, so for architectural design, this is from the word architecture. In this particular document, it will show what are our major modules. Okay, so the relationships among the major modules of the system. So in order for us to draw our architectural design, we base it on our DFD. Okay, so architectural design that you will do for your case study would be the structure chart. Okay, the one that I show you in our case study question, right? And then for the procedural design, or before that, why DFD? Because I believe I've mentioned when I brief you on the case study just now that your structure chart, okay, the number of modules depends on the processes in your DFD. If your DFD has 6 processes, means in your structure chart, you should also have 6 modules, okay, to show the major modules of the system based on your data flow diagram. Next is the procedural design. So what happened is that we will look at the description for your modules that you have included in your functional design or architectural design, and we will come up with the procedural design. Like I believe you all will learn decision tree and also decision table. Okay, in order for you to draw this procedural design in the context of decision tree and decision table, you will refer to the process specification. So again, it refers to not process. Remember, the DFD diagram 0 will show the main processes in the system, right? Like process 1, what is it? Process 2, what is it? So as long as you know what's going on inside each of these processes, that's why normally students need to draw up to diagram 1. Okay, up to diagram 1, so that you will know like process 1.1, 1.2, 1.3. So that's what happening inside that particular process. Okay, the process specification. Just to remind you all again that for your case study, I see that it's only up to diagram 0 lah. Okay, interface design is the, I believe you all know the data entry screen, okay, where the user will enter the data into the system, okay. We call it as the user interface design, right? And to do this, we need to look at our DFD. Remember last week we have seen one process called receive something. Okay, receive something, and then the input data flow is the same as the output data flow. You will treat that as an interface design. So if you are receiving customer order, that is where you should know that your interface design should include the attributes required for a customer order. Okay, like the customer name, the product that they want to order, the quantity, and then the user interface should also be able to have buttons, okay, buttons to submit or save and so on, right? So to do interface design, we will always go back to our DFD. Now, data design means your database design. So to design our database, we need to go back to our ERD, okay, and as well as the data dictionary that comes with it. Now, Next, you need to understand what's the difference between a logical design and a physical design. Okay, the keywords have already been highlighted to you. Logical design, okay, let me show you. These are logical design, and these are the physical design, because the logical design like DFD, data flow diagram, entity relationship diagram, it defines what must take place. Okay, what must take place. To contra this, in physical design, it will define how the system will be implemented. Okay, and then as you can see here, physical design, it is developed during the system design phase. Logical design, it is developed during the system analysis phase. Okay, look at the example here. Logical design for a customer record system. It will describe what will be entered for each of the customers. So we need to include the name, address, and so on, relevant to the customer. Okay, we're talking about the customer record. For a physical design, this is where we will describe how the data will be entered, the customer record, yeah, for each of the customer. So example would be the user interface design or the input screen layout. Okay, so logical design defines what must take place. Physical design defines how it will be implemented physically. Okay, so you do have this exercise where this is a very nice way of how to differentiate between logical design and physical design in the context of the phase, in which phase of our SDLC, what are the areas covered, the focus, and also example. Okay, we already know that logical design. Okay, we come up with the logical design in the second phase of SDLC, system analysis. Physical design in the third phase, system design phase, right? So logical design describe the what. Okay, so you can see the functions and features. Okay, so this is the what. Okay, what must be done. As for the physical design, it focuses on the how it will be implemented. So it is in fact describing the actual processes. Okay, the examples here are taken from the previous slide. Here describe what data must be entered. So list out like A, B, C, D, and E. And then physical design will describe how the A, B, C, D, E will be entered into the system. Okay, so your user interface screen design, perhaps one of it will be auto-generated, perhaps the system date and time no need to be entered by the user, and then user will be able to search from the database using the search icon, or perhaps a user can select from a drop-down menu or drop-down list box, and then there's some field that user need to type manually, and so on. So describing how the data will be entered. So far we have covered the importance of the design. System design is SDLC, the difference between logical design and physical design. So now let's take a look at the models used in the design stage. We will look at an example of system architecture. Okay. Okay, this is the structure chart that you need to include for your case study. We will not be using the system flow chart, okay? But then you will be learning a bit about the report layout. But for your case study, you only need to list the reports that you will include in your speed bus ticketing system. No need to draw design an actual report layout. Yeah, we already see the case study question. And this is in fact the UML, one of the UML diagram, which is the class diagram. So we're not going to do this also. So I will start with the architectural design. Okay, architectural design. Now, what is an architectural design? If you refer from our previous slide, architectural design, the keyword here is to show you what are the modules available in the system. So if you look at our description here, okay, shows the various modules. Okay, we want to see what are the relationship between these modules. So when we have the various modules, we can see the various modules available in the system. We have some sort of like an overview, okay, overall picture. So once we have the overall picture, then it will lead us to a better development process. And another thing is that, notice that I use the word modules. This is where one of the best practice, okay, in software development is to do a modular design. A modular design means we have one big system, but then we cannot develop the system as a whole. We need to separate it into smaller, manageable modules. Okay, so you can read here to develop modular program structure, right? And then one more thing that I want to emphasize is that most of the time this is being disregarded, okay, not included, especially in the agile system development where everything needs to be done very fast. But in a traditional software development, this is included. Okay, the first example here is an architecture design for a purchasing system. Okay, so we can see that the purchasing system is consists of the here would be the clients. Okay, one accessed by the customer, supplier, or other partners. So normally they will access it through their web browsers. Okay, and then this one shows the public internet as the connecting media. And then in the middle, we have the web server, which stores the web pages of information. I hope you still remember the web server, web browser, the one that we learned in the during one of the courses, the web page design and development. Okay. And then sometimes you also have database, but then most of the time, if this is a purchasing system, it should have a database where it will store orders, the items or the products, the accounting, sales, purchase, and many other things. Okay, it will also include, all right, application software used like the purchasing system. Besides the purchasing system, perhaps the inventory system, sales system, other system would be a sales system. So this is one overview of how it will look like, okay, for a purchasing system, online purchasing system. Okay, a system structure diagram will show the modules, how they are related to each other. And then there's another keyword, how the control information flow between them. Okay, flow between them. This is a system structure. Okay, an example would be the accounting system structure. Over here, we can see that for an accounting system, the sales order, all right, will be received as an input, and then it will go through the billing module. Once the payment has been received, then there's an accounts receivable module to do that, right? And then the billing info will be updated into GL, General Ledger. Okay, on the other hand, remember, I think I've shown you what is a PO, or right, invoice, bill, or receipt. Okay, once we have received the items that we want to purchase, all right, then the invoice will be given to us. So if you are the one who sell the item to your customer, then you need to prepare the invoice. Okay, so the invoice, when it has the payment has been made, then it will be updated in the accounts payable. Any one of you have learned or have basic in accounting?
Oh yeah. Me no.
Okay, good. Okay, next. The one that you will cover for your case study is what we call as FDD. Okay, so you are not going to draw a system structure. You're not going to draw architecture design, but you will focus on FDD. FDD stands for Functional Decomposition Diagrams, also known as structure chart. I believe this one is similar to what you have learned in your first programming course. It will show a top-down representation of the system, and then it will be separated into several subsystems or submodules. Okay, the functions are broken into lower level functions. Okay, and we use the DFD to create FDD, whereby diagram 0 DFD responds with the whole system, right? Means you have process 1, 2, 3, 4, 5, 6. Then it corresponds to module 1, 2, 3, 4, 5, 6. And then the low level DFD means diagram 1 DFD will represent the submodule. Okay, example would be, this is a customer relationship management system. It is consists of 1, 2, 3, 4, 5 modules. So we assume that the data flow diagram for this customer relationship management system, it has 1, 2, 3, 4, 5 main processes. Okay, 5 main processes. Another example is ERP. Okay, enterprise resource planning. In this system, it has 1, 2, 3, 4, 5 different modules as well. Okay. Next, functional decomposition. Here, why do we call it as FDD? Functional decomposition diagram means we want to decompose it into lower level functions. Okay, let's go back to the slide. We have these 3 levels. Okay, these 3 levels, depending on the size of the system, not all 3 levels will be used. Like we have business level, process level, logical level. Business level, it represents the various functional area like sales and marketing, accounting, and so on. Another level is process level. It represents the business processes, for example, the payment subsystem. So now, a good example of a business level FDD that represents various systems would be this one. In ERP is an enterprise-wide information system, a very big system that allows people to access all these systems. So I would say this is an example of a business level functional decomposition diagram, where each of the module represent the various systems included in this ERP. And then this is also the various system included in the CRM, okay, system or subsystem, right? Okay, process level FDD represents business processes or subsystem, for example, payment subsystem. This is what you all will do for your case study. Okay, you will do it in a process level, right? Using your DFD to draw your FDD. Logical level, it represents the procedures. So we use something like a program flowchart or even structured English. I'm not sure whether you all will learn structured English. I think when I go through your notes, macam tak ada. Right, but then normally students will learn this. Okay, the diploma student will learn this structured English together with decision tree and decision table. So that's why you can see there are various what we call as under architectural design. We have various examples. It is due to what? It's due to the let me go back. It's due to the levels. Okay, whether it's from business level or process level or logical level. Okay. Just now I mentioned that depending on the size of the system, not all the levels will be used. For example, a small system may contain one single level of details, while a very big system may contain all three levels. Okay. This is an example of a FDD. Remember your context diagram, which you label it as process 0, and then with the system name. So that one will be placed here at the topmost of your structure chart. So this is the system name, process 0. Normally, you don't do the labeling here, 0, 1, 2, 1.1, no need. This is just to show you how, okay, how starting from DFD, we create our FDD, right? Hopefully you can go back to this particular slide to refer to how you can translate your DFD into your FDD. So if you have two processes, then in your FDD, you will have these two rectangles. So process 1, process 2. Normally we call it as modules. Okay, this one is to fulfill the modular design. Okay, so this is context diagram. This is diagram 0, showing the main processes, the main modules. And if you go down a little bit more, this is representing the diagram 1 DFD. Diagram 1 DFD means if you explode process 1, then you will get 1.1, 1.2. Okay, and then if you explode process 2, then you will get 2.1, 2.2. So this is diagram 1. Now, if you explode the diagram 1 sub-processes, then you will get diagram 2. So diagram 2 for process sub-process 1.1 will become 1.1.1, 1.1.2, and so on. Okay, so this is let me refresh. Okay, this is referring to context diagram. This is the diagram 0. This is diagram 1, and this is diagram 2. The explosion from context diagram to the lower level DFD diagrams. Okay, example given here is a library system. You need to draw your for your speed bus ticketing system. Okay, this is a very good example. So this is the name of the system at the top. Okay, what are the modules included? So we can see that this is the business level showing the various system available. And then we have the process level here. For the library system operation, we have the membership management, okay, and then we have the add, remove books, loan management, and then the report. Okay. Yes.
Then when we do an assignment, do we only need to expand one of the module what for the bus ticket system only? Not do we only
for yours? I don't think you will include the rest. So for yours, then you don't see this part.
We still
bus ticketing system followed by what are the main processes depending on your DFD lah.
Do we still need all the boxes in the first level and then
buses?
Not boxes. All the other modules in the first level, and then we just go down one level and then do the bus system.
For yours, since you don't have the business level, kan? You just show the process level representing the business processes, means the processes from your DFD. So meaning, I don't think you will see this. Okay, straight away, this one will be here. Okay, because you don't have the business level. So under your bus ticketing system, then straight away, what are your main processes? Okay, and then for your case study, it says that you don't have diagram 1, but then in week 9, I can see that you need to explain the functions. So you need to show 4 main function, like 4 main function. So here I can see that for this process, say this is process 3, 3.1, 3.2, 3.3, and then 3.4. So you will only be able to describe the 4 main function for one of the module. If you can imagine during your DFD drawing, you have these sub modules. Okay. Right. Is there any example? Yeah, this is another example for leisure club system. Here it shows the business level here. So ini tak payahlah, straight away can add in the, I believe here, if you want to include only the process level, then you have 1, 2 main processes. But then, in fact, for your case study, you need at least 4 processes, minimum or maximum 6 processes, which includes the reporting and also the maintenance of the file. Okay. For inventory system, this is a very good example of a process level. A process level represents business processes or subsystem. Okay. Logical level represents the procedure. Represents the procedure means this one, the 1.1, 1.2, the diagram 2. No, this is diagram 0, diagram 1. Okay. Let's go back to the inventory system. So this is diagram 0. Okay, so here it shows the procedures to receive goods. I need to do this, this, and this. So you can see that these are the 4 main functions under receiving of goods. However, in this example, it only shows for one of the modules here, which is receiving goods. There might be others like to deliver goods, what are the functions? To do the returning of goods, what are the functions? Okay, what we have here is only one example for receiving goods. Okay, so before I stop the recording and we go for a short break, okay, these are the steps of decomposition. We define the system into 3 components: input, output, processing. So I believe this one would be input. Mana input? We need the PO. Enter items received would be input. This is processing, and then this one is output. Okay. Here in general, we can do this input. Okay, input, and then this is the output. Item management would be the CRUD. You all familiar with CRUD? CRUD? Create, retrieve, update, delete.
Yeah.
Yeah, that one would be under item management or maintenance lah, item maintenance. In this case, for inventory, whatever that the companies are selling lah. Identify the various activities that need to be performed. Related activities are grouped together into subtasks. Okay. Number 3, break the modules into smaller submodules if they are too large and complex. So that's why here this is we can break it into smaller submodules, right? Okay, next one is the user interface design. So let's go for a toilet break. Okay, 3 minutes and we'll continue.
Okay.
Okay, I'll start with the second recording. I believe we can see my slide, user interface design. So I add in this one. Here, for the user interface design, you need to recognize what are the various interface design. And in your case study that I've shown you earlier on, when you do the user interface design, you need to justify your design by mentioning what are the user friendliness characteristics that you have considered. Okay, here it says one of the most important feature of a good user interface design is that it must involve this user friendliness characteristics, and we will also learn about good user interface design principles. And then after this, we will go to the report design or output design, the various type of output devices, report, and the layout. Okay, let's start with the what is a user interface. From the name user, okay, interface, this is how the user will interact with the system. So it can be two ways. Hardware user interface means users can use various hardware devices to interact with the computer. Example, in the warehouse system,
Really like
cells are not warehouse staff or the store
I cannot hear properly.
Okay.
Miss.
So barcode scan is a hardware, right? You say okay, testing.
Okay.
Okay. Oh,
Yeah.
thank you for notifying me. My DG now shows H+. No wonder I'm breaking up. And now I've already changed to my Cellcom. the weather is not really good at my place. Okay, let me present my screen one more time. Okay, you can see my slide, right?
Yeah. Oh, yeah.
Okay. So if we use hardware user interface, we might the store hand might use the barcode scanner to enter the data into the system. But then if the store hand is using software user interface, then he himself will need to use user interface to enter the item data. Okay, manually lah. Okay, by using the keyboard. So these are the two examples of two ways of user interface, hardware and software. Now let's go through briefly, okay, what are the types of user interface that we have available. We still have command line interface. In the old days, we call it as DOS, where previously we don't have any graphical user interface. To do something, we need to type a command in the what do you call this prompt. Okay, during my school time, secondary school, learn a computer class means we need to bring our floppy disk, the big floppy disk. And to use the computer, we need to type from here. There's no user interface like graphical user interface at all. A menu-driven interface, I believe you have seen this. Did you all do this for your C++ or C#? Where the name C# with the menu, so 1, 2, 3, select an option, so type 1 and then it will go to that particular menu. So that one is a menu-driven interface. Now we have more improved menu interface. So we have this GUI. It can be a pop-up menu, pull-down menu, or cascading menu. And then I believe this is what you're doing now with visual programming, okay, a graphical based interface. And then toolbar and icon based, where I think this is a norm already, where you have the normal toolbar and then with the icons. And then the one that you will design for your case study would be something like this. Okay, a screen. Okay, a screen for your bus ticketing system. Design, I think it's only one screen, and then you need to justify whether or not you have incorporated user friendliness characteristic or not. Now, there's another type of interface. We call it as NLP. For NLP, it's for natural language interaction. Here, we need to talk. Okay, it will recognize our voice. Okay, so you can see the example here, voice entry system. Or besides using voice, I believe you have done this database query, whereby if you only want to see certain records from your table, then you will type a query, select all from what table. Okay, and then depending on what is your join, and then you specify the criteria where, and then that is an example of natural language. Okay, where we use English, okay, to interact with the computer system. Now, hardware devices, we have all these keyboard, mouse, touch screen, graphics tablet like pen, voice scanners, readers. I'm sure you have learned this in your introduction to IT. Okay, yeah, this is what I mentioned earlier on, whereby you somehow need to follow the user interface design principle when you come up with your user interface design. First of all, it must be consistent. meaning meaning all your screen should be the operations available for each of your screen should be activated in the same way. Say your delete button is a trash can icon, so throughout the system you should maintain the same delete icon. Okay, and then one more would be familiarize user. Familiarize user. This is normally what we encounter nowadays. We learn how to use Windows operating system, Microsoft product, okay, Microsoft software, and then it seems that the rest of the software out there in the market, it looks and feel almost the same. So this is what we call is we need to get our user familiarized. Say for example, you have several systems in your enterprise resource planning, then make sure each of the system is using the same term, the same concept, so that the user, the learning curve will be not that much. Okay, it will be faster for them to use the system. This is the third one. This is what normally the user will ignore, which is the guide user, because most of the time their reason is that, we don't have time, miss. We only managed to include the requirements. We didn't have time to do this. This is what we call the help. Okay, provide some tutorials or help when the user press F1 for help. At least there must be something. Okay, even in the design principle, guide the user is one of it. Okay, reduce surprise. You should never surprise your user. For example, you use a very loud alert sound. Okay, my first year student normally, because they are playing around with C programming, right? They learn how to alert those different alert sound. So whenever I check their assignment for error, they always include the alert sound until I said no need to add in some alert sound because really I get heart attack, because you don't normally expect that there should be a sound, but then they just do that simply. Okay, so reduce surprise. There are many types of surprise that you can reduce. Okay, and one more thing that I want to focus would be this one: enhance the recoverability. It means we do not penalize our user when they make mistake. For example, they enter the data and then they click save, or they select a record and then they choose that particular record to be deleted. So here, to enhance recoverability, you should show a confirmation box asking the user, are you sure you want to delete this record? This is, say, cannot be undo, for example. Okay, so if you don't have this confirmation box, then what happens is that the user, you are not getting the confirmation from the user, and then they simply delete the record without even checking. So means already deleted, difficult for them to recover that particular record. Okay, another example would be as simple as cancel button. Okay, cancel button, say they reach that particular screen and then they change their mind. Oh no, I don't think I want to edit this record. So at least there's a cancel button or back button. So enhance recoverability. Okay, 1, 2, 3, 4, 5 principles of UI design. Okay, what are the controls that we can add into our design? I believe you learned this in your visual programming, yeah. Even for your web design, we have seen what is a scroll bar, okay, a text box, checkbox, option button, drop down list. All these are examples of UI controls or components. Okay, now we look at what are the user-friendliness characteristics that you can include in your UI design. Now, why do we need to include this user-friendliness characteristic? Because we want to reduce the learning curve, okay, and then this will, at the end of the day, will reduce the time required by the user to learn using the system. So the first user interface characteristic is ease of data entry. Ease of data entry, okay, let's go to the next slide. It means the data entry screen should be in the same logical order as the input form. Okay, input form is your source document. Remember the case study assignment. Okay, initially a student need to draw or design the source document first, followed by the data input screen. But then for you guys, since your practical is only 1 hour compared to the diploma student 2 hours, so I think I believe that is also one of the reason why your case studies are much more simpler compared to the diploma students. So there's no need for you to design the input form. But then if you do have the input form, say you have a purchase order form, okay, the manual purchase order form, make sure the logical order is the same as what you have designed for your screen. Okay, easier for the data entry clerk to enter into the system. You need to carefully categorize the input area accordingly. Which one is auto-generated by the system? Okay, which one is retrieved from the database? Okay, which one the users need to enter? All right, you can use colors, and then besides that, make sure you name each of the fields properly. And for each of the input data entry, you need to have an input validation. This is where we want to avoid GIGO. What is GIGO? Garbage in, garbage out. So if invalid data being entered, then it will give us wrong output. Okay, here we will cover these examples of data validation check later. Okay, there's a range check, limit check, size check, character format check, and so on. So this will be covered. Second, meaningful error messages. So when you have a meaningful error messages, then you are incorporating user friendliness characteristic into your design. Here is an example of a poor error message. Means normally user will not have any idea what has happened and what he needs to do next. He only knows that there's an error, but then how do I fix this? So he just click OK. A good error message will inform the user what has happened. Okay, it's very clear, like this patient name is not found. So it's very clear, it's not unambiguous. Okay, and then suggest the user what he can do next. So this patient is not found, so he can either click this patient to see a list of the patients in the system, or create a new patient, or click help. This is a very good error message because it reports what has been, what happened, and then help the user to recover from the error by suggesting an action to be taken. Another user friendliness characteristic is to provide the help facilities. Remember one of the user interface design principle, okay, where you must guide the user. This is what we're talking about, the help facility. On-screen help, something like press F1 or click the help button, right? What are the different types of help? We can have a context-specific. Context-specific means help offered is related to relevant functions. What is the example there? Normally, if you see there's something like an eye icon, so when the user hover their mouse there and then there's an explanation, that is a context-specific help. Okay.
Oh, you also need help function also.
Help function, you can include this as one of your user friendliness characteristics. If
okay. Like what key does what, like that. What key use what function, those things.
Okay. So
Okay.
if say, where is it? Because you need to design your screen, right? So up to you. If you want to put like a small eye here and then hover, all right, hover over there, and then it explains something, example of format, or simply normally just display a text here, right? Example of say normally phone number, like phone number, there's a dash or without dash, or my card number, enter without dash. Those are example of help lah. Okay. Context sensitive help. Okay, let me see. So how about hypertext? Hypertext means you provide links between the topics, means user can click on the link and then provide the help. Here, I believe this is meant for online based. And then hypermedia means offers multimedia display. So some kind of a multimedia display. But then for your case study, I don't think this is necessary. More explanation on the context sensitive help is mentioned here. Okay, when users are unsure about a certain function, like for the my card, should I enter the dashes or not? And then normally we give an example. Okay, and then suggest a correct alternative to the command. And the reason why we include context sensitive help is that we want to save the user's time. Okay, rather than they call up the help desk, I have problem with this. Okay, that is very time consuming. If that can be solved by incorporating context sensitive help in your screen design, then do that. Okay, this is under help facility. Number 4, must be consistent with other modules. Again, this one refers to your user interface design principle. All right, familiarize the user, right? Where your module should be consistent. It should look and feel and operate in similar way. F1 is for help, F2 for save, for example. The reason we want to have this consistency, okay, to familiarize the user, because we will call this as transferable skill. If they know how to use it, then if they go to another module or another screen, then there's no problem for them to recognize what are the shortcut key and so on. So in fact, it will increase productivity. Cost saving due to reduced training time as well. Number 5, okay, adherence to industry standards. Okay, this one refers to what was the principle already? Let me go back. Okay, reduce the price. Oh, Okay, consistent design, familiarize user and reduce surprise. Okay, they are more or less like there's a overlapping in the understanding, right? Okay, so we have looked at consistency with other modules. Okay, and then the next one is the adherence to industry standards. Use commands and techniques that are used in other software application. Because now I think most of the software they're based on the Microsoft graphical user interface, and before that, Apple is the pioneer with the graphical user interface. Escapability is the also known as forgiving. Okay, as escapability is we do not penalize the user. So let's go back. This one, enhanced recoverability. So we refer to the escapability, right? Here, when the user hit the wrong keys or type the wrong command, as simple as you have the escape key or continue cancel, you are incorporating the user interface design principle. Okay. Now, what are the user-friendly features available that you can include? A pull-down list. Okay, this one will increase productivity. It will be more convenient rather than the user need to enter manually. Okay, pull-down list. Default values. Okay, default values is also one of the user friendliness characteristic because the value is already there. There's no need for the user to enter. But at the same time, if the user they want to change the default value, they can still do so, right? Example given is the red, which is the value added text. Sometimes the text is default. The rate of the text is default, say 10%. So just keep it at 10% most of the time. Then if the user want to change it, then they can change it. What else? What other default values like gender, male, female, depends on your scope. I'm not sure whether you should make it a default value, but then I do see some system, yeah, they put it a default into male and they need to change to female on your own. Okay, now I think for this part, I will do another separate video. Let's go for a 3 minutes break for me to do another recording.
Okay.
Okay, let me ready my slide. I'll start the recording. Okay, so to continue in this video recording of our lecture, we will continue with the input design. Okay, in this slide we see the three objectives of input design. Okay. The first one is we want to have a cost-effective method of input. If say rather than the store hand entering the data manually into the system, if we can use a hardware interface like the barcode reader, then why not? Okay. The next one would be to achieve highest possible level of accuracy. This is where we must have the input validation. Okay, input validation. And then the third one is to ensure that the input is acceptable, understood by the user. Okay, these are the types of input devices. I believe you have learned all of this in your introduction to IT, like the digital camera, right? Digital camera is an input device. Data collection device, normally this is used in a warehouse to capture the inventory data. Stylus pen is when we use the pen to write something either on the screen of a handheld computer. Okay, graphic input device. Graphic input device is similar to the stylus pen. And we also have RFID. Okay, RFID, most popular in inventory control system, radio frequency identification. Terminal means the computer which we use to enter data into the system. It can be a dumb terminal, which consists of screen and keyboard only, or a proper set of PC lah, with the screen, keyboard, and the CPU. All right, system unit. And the rest, I believe it's what you have covered before this, right?
What's MICR?
Magnetic input character recognition. Normally used in what kind of input we need magnetic for check processing. OCR is for the when you fill up form, or for your SPM you use your pencil, correct? That is OCR. MICR is for the check processing, whereby the check numbers are printed using the magnetized ink. So we need this MICR reader to read the magnetized ink printed on the check. Okay, good question. Now, exercise for students. Assume that we have a hypermarket, and then identify 4 areas. Okay, 4 areas of a hypermarket where input devices are used. Okay, example. In the warehouse, okay, you can use a barcode reader or RFID. This is very convenient. During checkout point, another barcode reader, also RFID. The staff working in the office purchasing department, he can use a keyboard. And in a retail store, digital camera will become input device, okay, especially when they want to do some kind of monitoring. Okay. This is what you need to include in your case study, the input validations. Okay, input validation, here we can come up with our own input validation, where normally we use programming. Okay, here we want to solve the problem of data accuracy, the garbage in, garbage out. So if you don't want to let in garbage into the system, you must do this input validation. Okay, therefore, as a conclusion, before data is processed, okay, it must be validated or checked to ensure the accuracy. Now, these are the types of data validation. The first one is sequence check. Here, the system will check the numerical sequence or whether it is in a correct chronology. Example, the data must be keyed in some predetermined sequence. Say in a HR system, there's a new employee just joined. So the staff ID, if it is a running number, then the next staff ID should be just easily done as +1. Okay, a very simple data validation is to check whether it is in a sequence, numerical sequence or not. If it's not, or out of sequence, if it's out of sequence, then error message should be displayed. A format check. For your database, I'm sure you are familiar with this format check, right? To make sure that the data conform to a certain expected format. Existence, also known as presence check, whether the data key in by the user exists in the database. Okay, if say it doesn't exist in the database, then we don't allow the user to proceed. Okay, existence check, presence check. I'm sure you're familiar with number 2 and number 3. Next is null value check. Okay, null value check whether the value has been entered or not. Okay, if you notice for our web development, normally we have the asterisk to signify it is mandatory or compulsory field. Okay, so that is null value check. And then as simple as data type check, whether the user enter numbers for a numeric data type or the opposite. Like for example, enter your age, so must only contain numbers. Size check to see a certain number of characters, whether it's fulfilled or not. Say telephone numbers must be 8 digits. For us, I don't think we can fix this. Like if it's a 011, there's an extra 1 digit. Okay, and then we have the handphone number and also the house number, the landline number. So it depends on how many fields that you want to include in the screen to be entered by the user. Limit check. Limit check, from the name limit, we want to see whether the data is not below a certain value. That's why we call it as a limit. Or we want to check the data is not above a certain value, right? Like the work hour, it should not be below 0, okay? Or the employee work hour should not be more than 100 hours. So we're checking the low limit and also the high limit. Now, but then if you want to combine both, then we call it as a range check. It means the data that the user enter is within the acceptable limits, the low and high, the mean and max. For example, in the range of 10 to 80 hours. So this is range check. I hope you all will not be confused with these two. Okay, this is either below or you want to check for above. All right, range check is between the range of the low and above. Check digit verification, this one requires calculation, whereby to verify that it is correct. Normally, a check digit will be calculated and then added to a code. Formula is normally will be included. And then when a particular code is entered into the system, then what will happen is that the system will recalculate the check digit and then compare it based to the what they have in the system. So if both check digit are the same, then we are verifying that it is valid. For example, would be bank account number. Okay, I believe this is also included in your case study assignment, whereby after you design your data entry screen, your user interface screen, incorporating the various user friendliness characteristics, you must also suggest input validation. Okay, let's see what are the suggested answer. I can see data type check can be done for address, means characters only, but then sometimes if the address contains numbers, I don't think this one would be applicable. Town, city, yes, this one should be okay for data type check. And then the postcode, yes, we can limit it to just numbers. What else? Format check for phone number. Size check can be done for phone number and handphone numbers. So these are just some of the examples of data fields that we can perform validation check. Now, when we consider our input design, we look at the volume, because some large volume of input requires automated input, say using the barcode reader. Frequency. If the data entry is not like that frequent, then as simple as using keyboard should be sufficient. Medium, which one is suitable? Software interface or hardware interface. Accuracy, we just covered this, which is the input validation, or if you use a barcode reader, for example, for automated input, then it will be very accurate. And speed. Some transaction requires the input to be entered immediately. Otherwise, then like ATM, there's a message. If you want to continue, press any key. Okay, because they don't want a long time of what to say, a long time of pause before the next transaction. Okay, this is an example of input screen. Not a complete input screen because I don't see the title of the screen here. It just have the title bar with the name. That's it. But then this can be further improved lah. And all this refers to what are the data needed to be entered into the system according to your process in the GFT. Okay, the next one would be the output design. Shall we split this to another video, or I can just combine this in this video?
Combine, sorry.
Okay. All right. So for output design, this is for report. Let's look at what are the factors that will affect our output design. First of all, we look at the purpose, and then the frequency of the output. Like, do we need the output every day, every week, once a month, or by the hour? Okay. Volume. Do we need the output in a very big amount of output? In this case, for printing purpose, we cannot just use the inkjet printer. We need much more faster speed printer. Okay, the commercial use like line printer. Output medium, either you display on the screen or it get printed. And then the content and format, here you can choose whether it will be a print out or video display. VDU stands for visual display unit, yeah. Okay, so these are the type of outputs. We have screen, audio, printer, plotters, COM, mobile devices. This is the automated teller machine, point of sales terminal, the visual display unit. Visual display unit means the monitor lah. Okay, so I'm sure you all have learned this in your intro to IT. Now, I add in a picture here. Identify 3 types of output devices used in airline industry. So here normally if you go to airport, you will listen for the announcement, right? And then you need to do your check-in. So I can see there's a kiosk here, and then the staff here will have their own screen, and then there's a small printer for printing, correct? So we have printer to print the boarding pass, speaker for the announcement, screen for the check-in, the kiosk also for the self-check-in. All right. Now, how about the types of report? If you remember, this is in week 13 of your case study assignment. Let's take a look at what are the guidelines for creating reports first. For input design, we have the user interface design principles, where based on the principles, we have some examples of user friendliness characteristics that we can include in our design. Now, for creating reports, these are our guidelines. A report must be designed for a particular functional area. So if the report is a sales analysis report, means it will be used by the sales department people. So we can say that this is a report for based on functional area. And then if you want to design a report, you need to look at the level of the staff. That's why earlier on in your case study, you need to draw your organization chart, right? Okay. Here is the operational level. Normally, they will need a very detailed report. For example, a detailed inventory report is meant for the salesman. But then for the sales manager, I don't think you should give him a detailed inventory report. You should give a summary, okay, a summary inventory report for the sales manager or even the sales director. Depends on the level of staff. The purpose of the report, it means if the report is to show the list of inventory available in the warehouse, then it should contain those information that are relevant for the user. Like for a salesman, they need to know the quantity. So make sure quantity is included in the report, right? Here, based on the purpose of the report, if you don't include a suitable information into the report, then it won't be useful. When it is not useful, then user will not be able to make decision. So might as well they don't print the report. Okay, so this is how I will check your report. Types of report. For detailed reports, here we have 2. One is sorted and uncategorized, and then another one is sorted but categorized. Why we call this as a detailed report? Because it will show every single item that we have in our database.
Why are the two detailed reports?
One is uncategorized, another one is categorized, means by, say, by this, I believe you have learned this in database, say invented a list of salesmen. So a list of salesmen that I have, then it will list out 100 salesmen in no particular order, perhaps in alphabetical order. And then I can also have a detailed report that lists out all my 100 salesmen, but this time I categorize it by region. But then both reports still show every single salesperson that we have, 100 records. Okay, so either you categorize it or uncategorize. Okay, is it clear?
Yeah.
Next is the summary report. Summary, normally from the word summary, you will see a total. Okay, and if this rather than showing lines of records, if it shows graphs or chart, that is also an example of summary report. Next, we have forecast report. We can see this from the title of the report, where it shows projection into future. And exception report, where we don't display every single item, but we filter the item based on a certain criteria. Perhaps the top 5 sellable items, or a list of customers who owed more than 5 months, and so on. Normally, exception reports is needed when the management must take action. Okay, must take action, like customer who owed more than 5 months means need to get the customer to make the payment. Top 5 sellable item, it depends on the management, whether they need to reorder more for this particular item, or perhaps give more goodies for the customer to keep on buying that particular 5 sellable item to maintain the momentum, up to the management. So exception normally requires certain action from the staff lah. Okay, this is an example of a detailed report where it shows every single item. Do not be misled by the title of the report. Okay, even though here it says summary, but it shows every single item. All right, this is uncategorized. Okay, and then this one is an example of categorized detailed report, where it shows by the person in charge. Okay, where you can see this is the subtotal, and then for categorized, since it is categorized by the person in charge, each of the person in charge, you have the control breaks. For example, the total for this person, and then the total is for all the person in charge. Okay, exception report. If you see, only you're not interested in seeing all the employee, but then you only want to see the employee with overtime hours. Okay, only the employee with overtime hours. So you can see from the name here, overtime report. So this is an exception report. Okay, summary report. You should be able to see totals. Okay, this is the total for this particular store, and overall would be the total for all the store. Okay, summary report. And next, a report design layout. Okay, here you need to know this, especially when you want to design very good report. But as what I see in the case study assignment, you only need to list out the report title, right? There's no need for you to design. Okay, so no need to worry about that one. So this is just an extra info for you. Okay, this one would be the report header. Okay, whereby normally the report header, we include the report title and the company name. Report header will appear only one time. Okay, page header will appear in every page. All right, and then look at the column space. Normally, you need to make your report readable as well. Okay, this one is extra. I got this from the diploma slide because they need to design their own report layout, right? If you are interested to get this, you can do a screenshot. In this slide, it explains what is a report header, what is a page header, what is a group header, detail, group footer, page footer, and report footer. Okay, it's just an example. Okay. And I think this is the last subtopic. What are the attributes of a good report? This is, I'll go through very fast. First of all, must have a very appropriate report title. Because otherwise, if the report title is not appropriate, then the reader will be a bit confused about the content of the report, unable to know what it will contain. Next, if you notice here, there's a space, okay, and then after each group total, there's a space, a line spacing, right? That one is in fact the pleasing report layout. It means a sufficient margins and spaces in between the data items. Next is a meaningful report content. Meaningful report content, it should be relevant. Relevant means content information that the user requires, means useful for the user. Other attribute of a good report would be, say if it's on-screen output, then there should be an indicator to show the direction. Next, previous, flip forward, backward, okay? And then if it's a printed report, then at least you should show end of the report. Okay, so this is to inform the user that he has reached to the end of the document or even the display screen. Or rather than showing end of the report, he can also put page 1 or 5, 2 or 5, 5 or 5, then definitely is the last page already. Means that other meaningful things that we can add to your report. Okay, since there's no need for you to come up with your source document, there's no need for you to design the source document. But then I noticed that in your slide, they still include this form design. I've added in this explanation. So this one is extra, so you can do a screenshot. In this example, this form is used as a source document to capture the input data. When you design the source document, you're done with the source document, then you will design your input screen. And you need to make sure that your source document tallies with the screen design that you will come up with, right? Example of a form design is this, where you can see that you should have heading, control, there's an authorization normally at the bottom, instruction here, and then somewhere there will be a total. you can see that at the bottom here is the authorization, the total, this is the heading, control would be the number and the date, and this one would be the body of the form. I think, yeah, in the case study, no need for you to come up with a source document. So you need to imagine that for your bus ticketing system, you have something in mind already to base on when you design your user input screen. But then for the diploma students, since they already designed their own source document, so what I did was I just compare whether the source document tallies with the screen design is tally with their source document. Okay, so I believe that's all. Okay, for our lecture today. Let's conclude by showing you your tutorial question. One moment. Okay, let's go back to the tutorial question. Oh, it's 1:30 already. This Thursday, okay, you have done tutorial 4, tutorial 5. Already allocate who will do what question. The first question is on FDD. Inventory system is available from the notes, so already add it in. Library system is also available from the notes. Okay, so next one would be Farah. Come up with the FDD for hotel system, Kelvin airline system. Question number 2. The case study is, the scenario is inventory system raw material for manufacturing firm. Okay, you need to design suitable reports that could be useful for staff at all levels of the organization. The staff or users may include those from other departments. So inventory system for a manufacturing firm. Okay, you need to identify 4 reports with titles. Must be useful to the user, the content, and for whom and what purpose. So I have included one example here. Example of report suitable for inventory system. Okay, so Noel give one, Farah give one, and Kelvin another report. Question 3, here you need to tell me what is the type of validation check based on the example given below. So Noel, Farah, Kelvin, Noel, Farah, Kelvin. And the last 2, I gave you the answer. This one is not in our what do you call our notes, page total control check, but this is the answer. This is a lower limit check. Okay, remember we have learn limit check, yeah. And for question 4, okay, for question 4, the last question, we know that some input need to be done manually. When it is done manually, a user will make a lot of mistakes and take time to complete the job. So you need to suggest 3 design areas that can reduce the amount of data input manually. So Noel suggests 1, Farah suggests 1, Kelvin suggests 1. This one is based on our notes. And that's all for the tutorial. I hope that is clear.
Yeah.
Okay, so that's all for today. See you on Thursday.
Okay, Miss. Thank you.
Welcome. Yeah, welcome. Bye.